Hi, I'm going to show this is one half of an octahedron. There's the square base, and here's the let's call it the origin. Let's say that this is a portion of a cube octahedron for now. Um, so the half of a octahedron volume is 2 tetrahedral units when the edge is 2, the long edge here from point to point. And we divided that by 4 into 4 sections, 4 equal parts. So there's a total, each part is 1/8 of an octahedron. So I've made other videos showing how you can basically phi scale the volumes, and it grows in this golden proportion sequence. I'm going to do that now with the 1/8 octahedra, and I'm just going to pick this. Okay, so if this overall distance is 2, let's say that it's 2 times phi to the 0 power, or 2 times 1. So then this length here is going to be 2 times phi to the negative 1. And then this length here is 2 times phi to the negative 2. Okay, so I'm going to do the same thing where we've extended, let's say we started out with this little 8th octahedron. We're going to extend a triangle to one of the new points. Okay, then what's interesting here is that it's going to be 0.618, a 0.618 increase in the volume. But what's even more amazing is that you add this tetrahedron here between these two faces, and we have this initial 1/8 octahedron with an edge 2 times phi to the negative 2. And we have an S module. So the S module is right here. It's those two tetrahedra added together. So that's a pretty interesting fact. And there is actually 4 S modules, and this is how they'd be oriented. So I'm going to go back here and get rid of that planes, those planes. And I'm going to try to quickly render what I just did to show 4 S modules. Oops, I don't like when it does that. Okay. Somehow I pick a point I don't even know. I think I know why. But okay, so now you can see here in this S module that this is actually an equilateral triangle. If I go into what's called icosahedral symmetry, then the 3 edges are the same color. But that is part of a icosahedron. In fact, I should be able to just touch on that. Whoa, that didn't work. Never mind. So anyway, there's a reason why that didn't work, but we won't get into it now. So we have essentially 4 S modules, and it does bother me that that didn't work out because I was kind of hoping to display that icosahedron. But it depends on which one how you start out. Okay, I know how to make that icosahedron. I didn't pick this point right here, which would be the center of the full octahedron. That's the center of the icosahedron. Now if I hit the icosahedral symmetry button, I have an icosahedron, and that shows 4 S modules. 1, 2, 3, 4. There's this extra line here, which is part of that smaller 8th octahedron. But there's your S module orientation with an icosahedron. Now this gets rather fascinating. That's why I'm bringing this up. Now if we extend the next, remember how we can go and make another triangle? And it's going to be here. I believe that's the right way to do it. Okay, now what we have is, boy, I feel like I screwed something up. I don't know why. I think I did. Yeah. I know what I did wrong. I meant to extend this edge here. Boom, 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 boom. Oops, and then the center. That really plagues me, that extra one being highlighted because I didn't want to back up. Okay, right here, this is pretty fascinating to me. is this volume here. That's, if I put this plane here, it's between that plane of what actually is part of the S module, but it's also part of the equilateral triangle of the icosahedron. The next, remember how the volumes are like, if you said relatively that this, if this lower octahedra, this 1/8, that's edge is 2 phi to the negative 2, its volume is actually phi to the negative 6 over 2 tetrahedral units. So this little triangle here, or tetrahedron between this plane and the octahedron plane, right in here, that creates the S module, that is phi to the negative 7 over 2 tetrahedral units. So if you add phi to the negative 6 and phi to the negative 7, both over 2, together you get phi to the negative 5 over 2. So what I find pretty interesting here is that this tetrahedron right here, and there's 4 of them, it's one of the modules that is the equivalent to an E module, but it's a peculiar E module, and this one is actually the P module of the PQR peculiar E modules. And this volume is, in this tetrahedron right here, is the same as one of these little 8th octahedron with edge 2 times phi to the negative 2. So then that shows an interesting generation of a 5-fold module inside of a 4-fold form, and it's pretty rationally constructed. And I just wanted to get that out there. And then, of course, the next larger tetrahedron is going to be the same volume as the S module, phi to the negative 5 over 2. Because so the tetrahedron between here and here is the same as the tetrahedron of the S module, which I clicked, but it's in S module is up here, but it counts the bottom 8th one too. So, and that keeps going all the way up. So you get your phi to the negative 6, phi to the negative 5, phi to the negative 4, or you can say that's phi. I'm adding them together, phi to the negative 3, then 2, negative 1, negative 2, negative 1, and then 0. So the overall 8th octahedron is going to be phi to the 0 over 2, because that's 8th of an octahedron is a half. Okay, so hopefully you got something out of that presentation. It's been something I wanted to get out there for a while. Thank you.